Okay, so in this video, we will be continuing on the beginner's guide to SDL2 in C++. So if you're just starting with this video, you will need to go to github.com, Programming Rainbow, Beginner's Guide to SDL2 in CPP. You will need to clone that repository. I'm just going to show where we left off with. So we are compiling this and we're going to run the demo. So we have the TrueType font as an image and it's bouncing on the screen. We can change the background color by pressing the space bar. We have an icon loaded. If you're in a floating window manager where you can see it, we also have the title up here called moving text and icon. So that is where we left off with in the last video. This video, we will be loading a player sprite and then we will be controlling it with the keyboard inputs, moving it around the screen. And so we are going to learn something new in this video, and it's not going to be how to load an image because we've already done that, but it's going to be how to get keyboard inputs that are not events, that are actually just keyboard state inputs. So the first thing we want to do is to load this new image that we have. So we already kind of loaded it because the image that we're going to be using is the one from the last video that we've already loaded as a surface of the CPP logo PNG, the image. We loaded this last video as a surface to load as the window icon. So we already have that as the surface available to us. What we need to do is we need to get the width and the height out of it to put into a rect, and we need to convert this surface to a texture. And we've already seen how to do all these things before, so we're just going to do that. I'm going to add some variables up here. We need the, get my notes real quick, make sure I'm on target. So we need a rect and we need a velocity. Yeah, I think that's about all we need for so far. So we'll have this SDL rect, and we'll call this Sprite rect. And then we're going to have a velocity. We only need one this time because we're not going to be changing it. We're going to be controlling the movement. We just need to know what speed it's going to move at when it does move. So we just need one, and we can put that as a const. It's not ever going to change. So we'll call this Sprite vel. Okay, so we have a rectangle and a velocity. So for this, for the rectangle, we don't really need to initialize. Do we initialize it here? Yeah, we did. So we'll just do it anyway. We don't really have to. But the velocity we do, it is a const. So down here we have the right down here. I'm going to put it right after these. So this one is going to be Sprite rect. And I'm just going to put 0, 0, 0, 0. And then Sprite vel is going to be 5. So it's a bit faster than the text. The text is moving at 3, which is a 60 frames a second. It's going to be 180 pixels per second movement, but it's actually moving diagonally, so it appears to be faster. But the player sprite is going to be moving at 5 per frame at 60 frames a second. That is 300 pixels per second. That's the rate of movement. I'm going to put a comma at the end of that one. Save that. Okay, so what we need to do is we need to get the width and the height. Since we already have this surface, was actually loaded in here in the game initialize, but this, what we're doing here with the sprite, is should be happening in the load media section. This was so we could load a sprite for the Windows surface, but what we really need to be working with is in here. So I'm going to, this is already here. I'm going to leave that, but I'm going to grab the width and the height like I did up here. I'm going to do it after. I'm going to put that at the end of this, continue on this load media function here with that. I'm going to be doing this exact same thing as up here. I can just copy it. I'll just yank this and bring it down here. And I need to change it from text to sprite. And this the surface that we're getting this from is called icon surf. That's icon surf. That again was from the last video when we loaded in the icon surf. Okay, so that will populate our width and our height for our rectangle. We're not going to be checking bounds with this rectangle, but we still need the width and the height so that it draws correctly on the screen. We're not using this rectangle for any bounds checking, but we do need still the rectangle to draw it correctly on the screen. So the next thing we need to do is be able to take that surface that we already have, that icon surface, and we need to turn it into a texture. And so that will be create texture from surface. We have already seen this before, so we're going to use this exact same thing. But one thing we need is a unique pointer to hold our texture. So I'm going to look for the last texture that was right here. This text right here is an SDL texture unique pointer, so I'm just going to yank that and put it here. And we need to change this. This one is going to be Sprite. So our player Sprite, like we've already seen before, is an SDL texture. And the deleter for that SDL texture is SDL destroy texture. So we've already seen this in previous videos. I'm not going to show it again. But that is going to be the unique pointer that holds our texture. And again, we've already seen how to convert a surface to a texture. This right here did it. So I'm just going to take this. This happened in the create text video, which was 2 videos back. So if you haven't watched that one, that's where all this is explained. So this unique pointer is Sprite. Whoops. Okay, and we're still using the same function. We're still using the same render, but the surface that we're using is the icon surf. Okay, that is the function. And now we also need to check this Sprite pointer to make sure that it got correctly created. Okay, so we have this sprite here and this sprite here. And error creating texture from surface, that is still the good error. And this is an SDL error, that's still all correct. So this is going to get our width and our height to populate our texture. And this is going to convert to populate our rectangle. And this is going to convert our surface to a texture. So now we have it in a texture. So the next thing we can do is just go ahead and draw this texture. And we're going to do it the exact same way that we drew the TTF, the text. So is it right here? Yeah, right here. We're using the render. We're drawing the texture. We're using the entire source, but we're using a rectangle that we are holding as the destination. So we're going to use this exact same one right here. So I'm changing the names for this to Sprite. I'll just walk through it. This is SDL render copy. This is how we render a texture to the, put a texture on the render. So we need to pass in the render. We need to unwrap the pointer. We need to pass in the pointer to the texture. We're unwrapping that as well. We're using null pointer to get the entire source. And then we're using the rectangle that we've already made. The X and the Y are zeros, but the width and the height have been populated with the width and the height that the sprite was before we converted it, or what that the surface was. But we could have actually used the query texture, and I'll show that to you as well. That would be the other way. If we went straight to a texture, we could query the texture to get the width and the height out of it as well. So this should allow us to just show the sprite that it's not moving yet, but it should show just fine if I haven't made any typos yet. It does say have an error in here, so I'm going to look for it. It's up here, and I believe I didn't initialize yeah, I did not initialize the pointer to null. So this will be Sprite, and it's null pointer. And then we have SDL destroy texture. Okay. I do kind of want to pull up the page. Let me just show that this works first, then I'll show the other way to get the width and height. Okay, now we have our C++ logo being displayed in the top left-hand corner. That's because it's at 0, 0 right now. It's being displayed right there where 0, 0 would be. And now we'll move on to moving it. But first I want to show you the other way to get the width and the height from a texture. Actually, what we'll do is we'll remove that way that we just used, and we'll do the other way. So imagine if you loaded an image directly to a texture and you didn't go through the surface phase. You didn't load it to a surface and then convert the surface. So you can't get the width and height out of the surface. What you can do is use SDL query texture, and this will query your texture, and you can get other information, but if you're most likely, you're probably looking for the width and the height so you can make your rectangle. So we have other stuff in here. For one, we need to pass in the texture that we're querying. And then the format, we don't actually need to pass anything in for this, I believe. So the format, we can just pass in null pointer for that. The access, we can also pass in null pointer for it. This argument can be null. So both of these can be null. This argument can be null if you don't need this information. And the access, if you don't need this information, yeah. Both of these can be null because we don't need them. What we really need is the width and height. And to actually get the width and the height, we actually need to pass in the address to the rectangle width and the address to the rectangle height. So you can't just pass them in as arguments. You need to pass them in kind of by reference. You need to pass in the address so that the function can actually change the data inside of it. So let's actually put that in, because that's the original way that this video should have gone. But since I put the icon in the previous video, we already had the surface and we kind of took a shortcut. But I would like to show this method in action, and this can fail, which is why I prefer to take it from the surface, because this one can fail, and then I need to check if it did fail, and it returns 0 on success, or returns a negative value if it fails. So that's why it's preferable if I have the surface to get it from the surface, but if not, this is fine. So we'll do it this way. What we're going to be inputting from this is the texture, null, null, and then we're going to need to populate our width and populate our height with the addresses of them. And we're checking this in an if statement to see if it failed. So what I would do is I would do this down where we're converting it here. Okay. Imagine if we were converting it or already loading it. After this, I would wrap it in an if statement. And this is this Sprite get. Okay, so that gets us the pointer to the texture. And then we have null pointer twice. And now we have width and height. Okay, so this is going to be this Sprite rect dot w, but we need the address of it. And the same. Sprite rect, and this is height. Now I think I'm missing a parentheses. There we go. So we wrap that in an if statement. Sorry, this is an if statement. So if this is 0, the if statement ignores it. That means success. If it's not 0, something went wrong. So we're going to put one of these failure messages in there, or the throw, where we create our message and then throw the runtime error. So this one will be error querying texture. I hope that's spelled right. Error querying texture. And this is a standard SDL kind of error. And we're throwing. Okay, so I'm actually going to use this way instead of this way. So comment this out. So hopefully if we've still got our width and a height, it should still display correctly on the screen. Okay, so it's still displaying correctly. That means we are getting the correct width and the height, because if we weren't getting right in the number, it wouldn't display correctly. And it looks like exactly the way it should be and exactly the size it should be. So, oops. So that looks like it's working. So I'm going to leave it this way. Like I said, I prefer this way if I already have the surface, but I want to show it both ways. So generally, you won't have a surface if you're just loading images directly. So you will need to use this other method. So I just want to leave that in there. So I'm going to remove this one because we're already doing that version when we do the TrueType font. So this one will use the query texture. And we're checking for the error. That's all good. So we have our image loaded. We have our rect populated, and we know that we can move it around the screen by by mutating X and Y variables in the rect. But we want to be able to control it ourselves. And so far, the only way that we have to get input is this SDL pull events. Now we don't want to do it this way. What these are events. So imagine when you press your key, the key goes from the up to down. Okay. Now, if we were at like 100 frames a second or 60 frames a second, just pressing a key, the key might actually be down for 10 seconds. But it doesn't count as 10 events. It counts as one event. It's basically an action from going up to down is an event. And that means if we were moving our character based on an event, if I press the key down, the key is down for 10 seconds, but I'm only going to move one time. And also the keyboard can repeat. So you get this thing where, watch, if I press the B, I'm going to press it, and it's going to show B once, and then it's going to start repeating. And then it starts repeating. I don't want my player to move like that. I don't want it to move once, pause, and then start moving again, and it won't even be moving fast enough. What I need to do is, instead of checking the event, if an action from going key up to key down happened, I need to just check, is the key down? Is the state of the key down? And we can do that. So the way that we do that is with this SDL get keyboard state. So what this is this is going to return a pointer to an internally managed SDL, an array. So this is not a pointer. We're not going to be putting this in a smart pointer. This is a pointer that already exists inside of SDL. When you start up SDL, it creates an internal array, and we are going to get the pointer to that array, and we can index into that array, and that array is basically your keyboard. So the way that we index into this array is by using the SDL scan codes. So if we have a pointer to this array and we index it with, say, SDL scan code 9 or space or escape or whatever we've been using, it's going to be 0 if it's not pressed, or 1 if it is being pressed. So it's nothing to do with what an up to down action occurred. It's just telling you right now, at this point in time, the key is in the down state. And that's what's important to us. If we see the key in a down state, we want to update this frame. We want to move it. Every time it's in a down state, we want to move it. So that's our state is changing every time the frame comes by and the key is in the down state. So it's not an event, it's just the state of the key. So we will hold on to this pointer. So that this function is returning us this pointer. So we're going to hold on to this pointer, but this is not a pointer that we manage. This is a pointer that SDL manages. So we're not making this a smart pointer or anything like that. We're not managing this. So this is just the pointer. And I believe if you put a number in here, if non-null receives the length of the returned array. Yeah, we're gonna put null in here for this. So returns a pointer to an array of keys. SDL valid whole lifetime. Yeah, this is an internal thing. Like I said, we are not doing this, and it's going to be 0 or 1, which is true or false. In C, C++, 0 is false, 1 is true. So 0 means the key's up, 1 means the key's down. If we wrap this in an if statement, so on and so forth. And this gets updated every time you do an SDL pump event, but what it's not telling you is it also gets updated every time you do an SDL pull event. When you do this SDL pull event, the pump event actually happens as well. So we just need a pointer to this, and this is going to be updated every time we come through our frame. This is going to be updated for us. So what we're going to do is we're going to hold I'm going to make a member variable for our class for this. This is going to be a const uint8, and it's going to be a pointer to a key state. And again, this is just going to look like a raw pointer because it's not something we're managing. It's something that SDL has. It's its own thing. So const uint8. So we have this const uint8 pointer to key state, or key state is a pointer to it. Const uint8. I always get them confused. But anyway, it's a const. So we've declared that this exists, but we actually need to get we're going to do this in the initializer list. Okay, so this is going to be right before, it's going to be right at the end of the initializer list, or right before these smart pointers are dealt with. So what we're going to do is right here, we're going to populate this, get the address to this pointer. So we're going to say a key state, and we'll use the unified initializer. And we're going to use this function here, that is the SDL get keyboard state. Okay, so I'm going to put that in there. And we're just passing in null pointer to this. Okay, so that is going to set up our array. Well, we're not setting up the array already exists. We're just getting a pointer to that array. And then we'll be able to index into it to check each key that we want to check. Let's just make sure that that's good. I'm just going to compile it just to make sure there's no errors before I continue on. Okay, I'm not going to run it because nothing else has changed. So we have this set up. So what we want to do is we're going to make the way that we were updating the text, we're going to make a new one. So we need to add that in as well. So right here, we're going to have void update. We could say player sprite. Let's say sprite. So update sprite, and we'll go down below our update text. Where did I put it? Update text is right here, so I'll just go below that. I'll say void game update sprite. And before I forget, I'm just going to add it in here. So remember, these are checking events. This is mutating game state, and this is drawing everything. So I'm just going to put it here. So that's where we're calling it. Now I'm going to fill out what this is going to do. So what we need to do is we're going to start checking if they're pressed, basically. And then if they are, we're going to move our player. So we can say the left key. That's pretty easy. So if we'll say this, key state, and we're going to index it. And we're going to use one of the scan keys. So if we look over here at the scan code, there's a left. There it is. We have a scan keyboard left brace. We just have a left one. Where is it? There it is. SDL scan code left. That's the one we're going to use. And there's an up, a down, a right. And we can also use ASWD. So this will be SDL scan code. I'm just going to take the 1 there and then change it to left. So if this key is being pressed, what do I want it to do? I'm just going to update the rectangle X position with the sprite velocity. But since we're moving left, it's going to be a decrement, it's subtracting from it, it's not adding to it. This sprite rect dot X, and this one's a decrement, so I'm going to say minus equals this sprite rect, sorry, not rect, val. So if we're pressing the left key, we want to move to the left, and the way to move to the left is by subtracting from the X to move it left. So if the left is pressed, we're taking the sprite rect X member and we're decrementing it by the sprite velocity, which is going to be 5. Each frame that it finds out that this is still in the down state, it's going to decrement it by 5. So we can also, besides checking left, we could put the OR logical operator in there, and we could check another key. We could say this keyboard state, and we could say SDL scan code, and I'm going to pick left again, and this time I can say A. So I can say left or A. If left or A is pressed, then do this. Now, I actually am not going to use an if-else on this. The reason for this is, if you think about it, if I press the left key, and if I were to continue this, if like else if, and I check the right key, what's going to happen if I press both the left and the right down? If I press the left, it's going to go left. If I press the right, it goes right. But if I press the left and right together, this if statement is going to be true for the first one, and it's not going to check the else. So what it's going to do is it's going to move to the left. Now, I don't want it to do that. I want it to not move at all. So what I'm going to do is I'm going to have an if statement on the left. It's going to move it to the left. And if I'm holding right down too, I'm going to have that if statement, and it's going to move it back to the right. And it's going to end it up where it stopped, where it started from. So let's just check to make sure left works before we move on. So I'm going to press the left arrow. Yep. I'm going to press the A. And I'm just touching it a little bit because I just want it to move a little bit. I'll show you smooth movement the other way. Okay, so like I said, I'm not going to do the else. I'm going to do ifs on all of them individually. So I'm just going to paste this in. Okay, so we have left. This will be right. And right and D. Okay, and this one, instead of decrementing, we want to increment. So we got the left is decrementing and right is incrementing. Now on the left for the decrementing, we could say up, that will decrement, and up will also be W. So they have the up and the W, but the problem is we don't want the X decremented, we want Y decremented. And this one, Y will be incremented, and we'll say down, because Y, if the Y gets bigger, we're moving down. And then we'll say S as well. Okay, so that should give us our movements of the different directions. We're just going to recompile it. Okay, here we go. So I'm going to just hold down right. See, that's smooth. And down, left, and up. And D, S, A, W. Now I'll hold A and left at the same time. They should both go left, but we don't go twice as fast. We just go the same speed. There's both right. Now I'm going to hold A and right. Those are opposites. A and right, and I'm not moving. And say D and right and D. Those are opposites. Or right and left. Those are opposites. Up and down are opposites. S and W. And we can go diagonal. We can just move whatever way we want to move. Now diagonal looks like it's going much faster. That's because we are kind of going faster. We're moving 5 pixels to the right and 5 pixels up, which diagonally is more like 7.5. It's not 7.5, but you know, it's you get the idea. We're not normalizing direction here. This is just simple movement. So we can go off the screen. We can come back on. That's just going to show you how simple movement's done. And again, this is just checking the key state, if the key is in the down state. So it's always going to be smooth. It's not going to be something where the key happens one time and then it starts repeating on you. And we still have our colors. So this is anytime you're doing movement, you want this. If you want an action to occur, you do the event. But if you just want smooth movement, you need to use the key state. Okay, so let's see, where are we at? So that is in there. So what we did here is nothing new happened here, but we do have a new private member function here. That's their update sprite. And we do have a new rect here and a constant sprite velocity. We also have this pointer to the internal keyboard state. And we do have this new unique pointer to the texture for the sprite. And that is the sprite rectangle right here and the sprite velocity right here that we're initializing, and the pointer right here, the sprite pointer. We also have where is it at? Right here, the keyboard state. We are using the SDL get keyboard state. We're passing in a null pointer. This is returning the pointer. This keyboard state is holding this pointer. And again, we're not managing that pointer, so you don't have to worry about memory leaks or anything. And we already had the surface. We already had the surface to deal with. So what we did is we converted this surface. Where is it? Right here. We've converted the surface to a texture, and then we've queried the texture to populate our width and our height for our rectangle by passing them in as address. So here's our update sprite right here. And we're using that array. We're indexing into it with the SDL scan codes that each one represent which key you're looking at, and it's a 1 if it's down, so we can wrap that in an if statement like we have, and we can use the OR logical operator to have one or the other be impressed. And we're updating either the X or the Y to move it around, and that's happening each frame. So we're calling that function right here. After we're checking events, we are updating. So we're updating the text, and then we're updating the sprite. And I believe that's everything. Yeah. So that's going to be everything for this video. Hope you enjoyed that. That's how you load a player sprite and how you move them around with smooth movement using the keyboard state. Again, thanks for watching. Bye.